Hi, my name is Frank La Vigne. I'm the global GTM sales lead for data services here at Red Hat. And with me today is Joshua Blumert, or Josh, and he's the worldwide technical sales leader for IBM Storage Fusion. And he's going to talk to us all about storage in the Red Hat / IBM world. Welcome to the show, Josh.
Thank you.
I understand you have some cool demos for us.
So I do. So yeah, I wanted to talk about, so since the beginning of this year, which just came up, we have brought the Red Hat portfolio over into IBM. And with that saying that is I wanted to kind of explain what we're doing as far as offering the Red Hat storage offerings now as part of IBM's storage offering. And what I'm focused on is providing storage for containerized environments, something that Red Hat's been doing for a while now, and something that we've been doing, but now we have the benefit of using the offerings from Red Hat as part of our portfolio. If that makes sense.
That makes perfect sense. This is great because I am but a humble data scientist. Which is funny because data scientists are not really that humble.
Right.
But this whole containerized world is still something that's relatively new to me. In my background, I tend to focus on the Python and the algorithms and whatnot. So kind of the infrastructure side of things is relatively new to me. I've done some data engineering, but that's mostly in the context of cloud offerings and kind of SQL transforms, ELT. So this is going to be a really good lesson for me to learn too, and hopefully for our audience as well.
Well, that's cool because I'm probably the other side of the coin from you. I've always been kind of a Linux and infrastructure type person. So my career has been spent worrying about providing the foundation so that you could do your job.
Well, awesome. I think this will be a great learning experience for both of us.
Right. So, and you talk about containers as being a brave new world, and I'm sure many of our viewers may know this, but I just look at this as the next great progression that we've done in the computing world. We started with operating systems that were loaded directly on bare metal, and we did a lot with that. And then this major revolution came where we started doing virtualization. And what that did for us was we took that OS that was running on a physical server and we packaged it up and we made it portable and we made it easy to deploy, and we weren't tied to the hardware anymore. And that was super cool. And that allowed us to run our applications and not have to worry about the physical layer because we were just running on this virtualized layer. It did have one thing that it didn't fix, which was you were still carrying an entire operating system around with you. So you were running your application, but you had to have a full OS. So that VM was pretty heavy, something to point out. And then we said, oh, well, we can just have the application. What does an application need to run? Well, it really needs is the libraries that support it, and that's it. So if we can just provide that application the libraries it needs, and then it's going to be a lot smaller in form factor. And so what went from, gigabytes of utilization became something really compact because we just had that application and pretty much just the code to run that application. And we kind of came up with a new way of virtualizing our environments. So that was a kind of a cool shift. And I think, people were really embracing it.
Yeah, I mean, you're right, and from sure folks who are subscribed to this YouTube channel and watch this, containers are not a brave new world. But you have to remember that there are a lot of folks out there that to them it is brand new. Right. And I remember one of my first jobs was I was the developer team lead that coordinated our deployment on actual physical servers in our own data center, and there were actually testing that we had to do to make sure certain DLLs would play along with certain other DLLs, right? So we would actually have to we would actually have to do a lot of testing to make sure this application could live on this server and coexist on the same machine as the other one.
Right.
Virtualization took away a lot of those problems, but it created new problems.
Right.
And like you said, we had to bring the whole thing with us. So, suddenly now we had our memory requirements and disk requirements went through the roof. And as that's when I left that world and marched off into the data side of things, I didn't really have to think about virtualization anymore. But I remember thinking like, there's got to be a better way.
Right.
And as I come back, this turns out containerization was the better way.
We actually were, I would say about 10 years ago, we were thinking about this because we were building, I was working on building high performance computing infrastructure. So building out these big, massive grids of servers. We took all these 1U servers, we stuffed a rack with as many as we could. So you'd have like 40 or so servers in a rack. And we wanted that super easy to deploy. And so how do we do that? Well, we would pixie boot the servers and we'd load the operating system. But we said, really, there's nothing in the operating system that is specific to the application. So why can't that OS be ephemeral? And that's exactly what we did, is we took Red Hat Linux at the time, and we said, we're not going to install it to disk. We're just going to install it to RAM. And it's just going to live in memory. In fact, there were some people who went a step further, and there was a project called Linux BIOS. I don't know if you remember that or heard of that.
I've heard whispers of it, but what exactly does that mean? And obviously,
So
BIOS is
instead of having a BIOS, that 16-bit BIOS of the day, and now we finally got to a 64-bit UEFI, but we had that 16-bit little BIOS, and that would boot and literally boot the machine, and the hardware would be up, and then we would load our operating system. So what if we just put stripped down version of Linux, and the system, when you powered it on, immediately just turned on into Linux? Your boot time goes from several minutes to kind of several seconds, and
interesting.
So boot straight in. So literally power on the box and get to a command line prompt almost instantly. So kind of this is what containers kind of makes me think about, because you're stripping out all that stuff that you were building that you really don't need, that infrastructure stuff, and you just really just want to get right to your application. And it's totally ephemeral. You store things someplace else, which is what we'll talk about. And not to date myself, but it's kind of the VCR model of computing. VCR doesn't work. You just power it on, power it off again, and you're ready to roll, right? It's the same kind of thing.
I'm trying to think what the kids today will understand.
Yeah, I have to go find my rotary phone. So
that's right. That's funny. No, it is interesting how this technology has evolved, from you would have actual physical servers to then you had virtualization, and then now you have containerization.
Right.
And we'll talk about kind of how storage works, because if your OS is ephemeral, the only thing that really matters is your long-term storage.
Correct.
And as a data scientist, right, like I don't, not that I don't care about where the data is stored. I care about the data. You know what I mean? And we've seen kind of the evolution of this, and I call this the Costco test, right? So how I came about the Costco test is the idea that a few years back, I was interviewing for a position, and this one firm I was at, it was not a good fit, and I could kind of tell this at that point. But and this was like 2016, and he was so proud, so proud that he created a 6 terabyte database.
Oh.
Right now, kind of pulled some threads on that. I found out that this was the project that elevated him through the ranks of the company. So he was a little bit too attached to it, maybe. And I didn't really have the heart to tell him that in 2004, when this was built, getting 6 terabytes of storage and working with a database engine was a feat of engineering in and of itself.
Right.
However, by the time 2016 came along, 6 terabytes was no longer big data.
Right.
And, they for various reasons, the rapport and the overall position, the interview didn't really go my way, and I'm okay with that. But I ended up on the way home, my wife had asked me to stop at Costco. And what do you see in Costco? And they've since changed the layouts, but in this Costco, you walk in, they have the portable hard drives and the electronics there. And right on the front of the desk was a 6 terabyte hard drive at the time. And that kind of gave me an insight to what I call the Costco rule, right? Like if you can walk into not just Costco, but any kind of big box retailer, and you see the amount of storage that, that is, then that amount of storage is no longer big data. Right. It's kind of, it's a moving target. Now, what's interesting with the cloud and things like that, all you have to do now, at least if you're dealing with the cloud, is to requisition more storage, is you just basically, you ask for more storage.
Right.
In some cases, they'll even automatically do that. You only see the bill at the end of the month or the quarter. But I mean, the whole notion of data storage has also evolved too. Now, obviously, for on-prem solutions, you still have to requisition hardware and stuff like that. But it's my understanding that ODF and Ceph containerize that, for lack of a better term. Am I right about that, or am I wrong about that?
No, you're totally right on board there. We want to provide you. You're right. You are the data scientist. You don't care what the storage is. You just care that it's there and for you, and you can read and write to it. And then when you come back to it, it's still there, right? So you just care it's protected, it's performant, and that you can, and it's ubiquitous. You can get to it from anywhere. Actually, as you were talking, there's one rule about storage. Somebody told me once, and it's a really good thing to think about, storage when we think about disks is binary. And what do you mean by that? It's either new or full. And I look at all my hard drives, and it's exactly true. I have brand new disks and I have full disks. There's nothing in between. Because you get a drive and you just fill it, and then you go, okay, I gotta get another one, because nobody deletes anything anymore anyway.
Well, it's true. Storage is the cheapest it's ever been. It's probably gonna get cheaper. One of the few things in this world that is prices going down. But also, I noticed with my various cloud accounts, it'll say, hey, you're at 80% of your storage, right, on your, say, G drive, and then when faced with the dilemma of, well, should I go and delete stuff, or should I just pay like an extra $2 per month? Yeah, I'm sad to say that, I think we're all becoming digital hoarders, so to speak. I know I am, but you're right. I mean, the cost of my time to go through and kind of get rid of stuff, balanced with the cheaper cost of storage to just add more, leads me to just add more, which I'm sure that there's a lesson there maybe to be learned, but and at some point that I may go and purge a lot of stuff. But you're right, people tend not to delete things. And when you're dealing with enterprises, I'm sure there's regulatory things that need to be kept in mind, how many years you keep it. And there's various cloud services kind of take that into advantages. Previous employer, they had cold storage, where basically it cost nothing to store. Well, not nothing, but it was really cheap to store. But if you never intended to access it, unless there was some kind of investigation, the cost to retrieve it
was high,
was very expensive. So it was kind of that interesting kind of the economics of storage, at least from my simple data science mind, is the idea of you buy equipment, you fill it up, you buy more, right? That was kind of how it traditionally has been. Now it's a little more nuanced, because you can kind of scale up and scale down. You can use archival features. You could it's become a lot more multidimensional than simply that binary aspect that you mentioned, new drive or full drive.
Right. Well, I mean, you just would have singular drives and you protect it by RAID, but if that failed, you'd have to go and procure another drive and fill it in. You're managing storage, and you're a data scientist. You don't want to be managing storage. You want someone else to do that for you.
Absolutely. In fact, I know a lot of people that, if you even say the word RAID, they have no idea what you're talking about. Unless they had done something else prior to switching to data science. That, I mean, it's basically, why can't I get to my Jupyter notebook?
Right. You remind me, the other thing you reminded me was I did watch the progression of storage getting cheaper in a very interesting way. I had my IBM ThinkPad, and the ThinkPad had an interesting feature. You'd have an internal drive, and I discovered that you could pull out the CD-ROM that was removable and put another drive in there. So what I discovered I could do was I could be running with my internal drive, and when it got full, I wouldn't purge anything. I just go out and buy a new drive, and I copy all my data to that secondary drive, and then that would become my new drive, and I move it into the middle of the system, and then I was happy I had a larger one. And I noticed that like every year I was able to at least double my capacity by buying a new drive at the same price I bought my drive last year. So merrily going along on Newegg, sorry, shameless plug, but buying larger hard drives every year and just swapping them through my system just continuously. And actually the laptop would change too. I would just, every 3 years, IBM would send me a new laptop that would just go away, but I'd keep the hard drive. And I just swap in the new hard drive, and that was the beauty of running Linux too, because I didn't really care. I wasn't running Windows, and I had to worry about all the drivers. I was just running Linux, so I would just like swap the drive. Boom, Linux would boot up. I'd be happy and running again, and I just kept on doing it. I won't say what version I was running.
Well, it's funny you mentioned the driver replication would be an issue, which I think. I hadn't thought about like saving the driver files, which were precious once you figured it out.
Right.
Hasn't really been a problem for at least 10 years, maybe longer. I would say Windows 7 is about the last time I had to think about that. So for you kids out there, you really don't know how good you have it now.
Oh, well, there was a technique that was written up in Red Hat. How did you take your installer CD of Red Hat, and unroll it, inject your new drivers, rebuild it, and then hand it out to somebody so it'd have all the drivers. And that was something you had to do in the early days, was essentially unpack the bootloader, the boot section of the code, of the Linux kernel, rebuild the kernel to have all the drivers you need in it, and then repack that CD-ROM, and then boot from that so that you would have the drivers you need.
Wow,
that was challenging and painful.
Even just saying burning a CD, I think there's a huge. So it's funny. I remember my son was born in 2009, right? And if this was maybe 4 years ago, we somebody had like a wedding, and they wanted a particular song to be played, and for some reason, where the venue didn't have like an MP3 jack or anything like that, so they said, "Hey, could you burn a CD for me of this song?" And I was like, "Sure." And then my son, who was a bit younger at the time, was like, "Oh, cool, we're gonna burn a CD. Like, I have to see this." And the other thing first thing he said actually was, "What's a CD?" Which
What's a CD?
That was a punch to the gut. But then he was very disappointed when there was in fact no visible burning involved.
Oh,
when it was just we put the thing in there, and now burning a CD is pretty, if it's done at all, right? Like became pretty anticlimactic. You drag the file over and you hit go, right? I remember when it was a nightmare to get the driver going, and it was we should do is just show just to technology reminiscence, right? But we're here today to talk about kind of the evolution of storage, and so tell me more about what ODF and Ceph is, and what the relationship between Ceph and ODF is.
So Ceph is where we should say we should start with Ceph, because Ceph at its heart was the ability is a storage file system that was created to solve scalability issues, right? We were in, I talked about HPC, big data, something you're doing, and we need to write lots of data. We need it to be highly available. We want it to be cheap, right? There are things you talk about, there's always talk about you can be cheap, you can be reliant, and you can be fast. You can only get two, right? They always say that. You cannot have two.
That triangle, yeah.
Yeah, that's the triangle. Pick two, because you can't have all three. Well, In Cephs, we want to have all three. We want it to be cheap, so we want to build it on commodity hardware, right? We don't want to have to use specialized hardware that to get what we need, because that's expensive. So we really want off-the-shelf cheap hardware. We talked about these cheap hard drives you can buy. We want it to be fast. So in storage, of course, we're at SSDs now, but before we had SSDs, we pretty much were living on spinning drives, and those were always throttled by the transfer rate, because you had to literally wait for the head to move around, right? And then you could read your data, and then if you missed, you had to read again, and you had to wait for it to come around again. So that rotational latency was a challenge. So how do we solve that? Well, if we have a lot of drives added together, we're aggregating the performance, because we can spray our data across multiple drives, and we can get performance. So we know that spreading out across lots of drives gives us more performance. Has been one of the traditional tenets of storage. Is parallelism is easy to get and take advantage of it. So we want that, and we want high reliability. And we know drives, especially if they rotated at that time, had a high chance of failing because they were physically moving. So anything that moves wears out, as I can attest to you from running every day. Things wear out. Yeah. So and then that's a problem. So you have to perform maintenance. Well, in my case, stretching, but and make sure that you feel better. So the same thing with disks. So again, as you get lots of drives out there, you got to worry about maintenance. So we have to worry about, well, I don't want to worry that a drive fails. I just want to keep running. So Cephs was the attempt to build out a file system that would scale out, perform, and was cheap, right? So that's kind of the thought behind that.
So here's a question that I know my data scientist friends would want me to ask. How does that relate to Hadoop file system or HDFS? Like, was that developed in parallel? Was one a precursor to the other, or is that not even a good question to ask?
No, I think the Hadoop model may have come first. And Hadoop, remember, wasn't originally a POSIX file system. It was its own.
Sure.
It was its own access. It was a Hadoop layer, but the concept there was similar. What did you have for storage at the time? You had individual hard drives going in servers, or you had SANs. SANs were cool because you could build these expensive arrays or buy these expensive arrays to protect your data. But they were also represented that something that the data scientists like you found out very quickly. It was a bottleneck. Mm-hmm. Because if you're a data scientist and you're doing lots of compute, you're using hundreds of servers, right? You're thinking hundreds, or thinking thousands if you're really in a big organization. And you can't if I spread a workload across hundreds of servers, all those servers talking to the same storage array at the same time. The thing is just going to give up. You're going to saturate your SAN, or you're going to saturate your storage array, but you will hit the limits of that very quickly. And so from a data scientist point of view, when you're doing high performance computing, local disks actually are faster, right? Because I guarantee to get the bandwidth to that little local drive. And I've had a bunch of local drives, and hey, this is great. I'm doing better than my SAN because I'm just direct attached to these drives. So what if I just spray my drive? I just fill all my servers with disk, and I just spray them with disks, spray them with the data across all of them. Well, then I got to worry about what happens if something fails. Well, just make another copy of the data, right? So let's not run RAID algorithms are bad, because traditionally a RAID algorithm, when you're writing data, and then parity, and if a drive fails, oh my God, my drive failed. So now the system basically says, okay, I'm going to read data, parity. I'm missing that data. So now I compute the data that was lost. Okay, that's expensive, because now I'm spending my time, and the performance now goes to hell. So a drive loss is just a horrible thing. If I'm just spraying my data across all the disks, and I have multiple copies, then if one of the copies fails and goes offline, okay, I just in the background just bring it back to full parity again by just rewriting the data that was lost. It also saves me this concept of, and the D-RAID guys finally figured this out, is that only need to recover data, and in the old-fashioned RAID drives, we didn't know where the data was, so we just had to rebuild everything that was on the drive. So if you had a large hard drive and it failed in a RAID set, you had to rebuild the entire drive. That's really painful. While if
I've known people who had to do that, and
just the most awful thing in the world. And RAID is just, so if we're just spraying our data across multiple servers with multiple drives, so then I'm just got multiple copies again, it solves that problem. And then performance, my data is all sprayed out. I just read it from the closest place, right? So wherever my data is, I read it from the closest location. So again, that's kind of the concept in CEPS, was to build out a POSIX file system. One of the things they wanted to do, they actually wanted to do several things, but one of the things was to build out a file system that was spread out across lots of servers, so the performance was really good. But they also wanted to service the fact that there's other ways of reading data besides POSIX. So they also wanted to provide object storage. So same thing, they provided object store. And they also wanted to just have block storage, because there are applications or things that just need block storage. And so instead of giving somebody a hard drive, we want to give them a virtual hard drive and let them use that as their block storage. So the CEPS was built to solve that. It was actually a government project. I don't know if you knew that too.
No, I did not know that. Interesting.
It was funded by, I believe it was I don't know what section, but it was a federally funded project for building for storage. So that was, they felt that was needed. And so I think it was built at one of the labs on the West Coast. Good to be East Coast oriented here, but I think one of the big labs out on the West Coast was where it kind of started. And then there was at some point a company that actually was selling CEPS that I think Red Hat acquired. So now you're stretching my memory of.
Oh, interesting. This is all history I didn't know about. I knew it was an open source project at one point, and then became. So what is the relationship then of Ceph and ODF?
So now we're sorry from all that. The container revolution is occurring, and we need storage for containers. And certainly the model that, my understanding is that the model that we went down was a lot of it was based on object stores, right? I wanted my application. This is the whole thing where they talk about cattle versus pets. I'm running code. I just want my code to be ephemeral, meaning there's no state in my code. My state is elsewhere. So I save state to my storage, but my code is just my code. That simplifies things a lot. And that way, if my application fails, just like cattle, you shoot it and you restart it, right? The same kind of concept there.
And you're not attached to it, right? It's not like a pet.
You're not attached.
You don't give it a name. I remember, naming conventions for servers at one point were a big deal. Now I don't think anyone really cares. Like it's just.
I always liked naming servers. Yeah, I guess I was a pets kind of guy, because that was one of my thrills. Yeah. Sure, you had how much of a life I had, was coming up with interesting names. Of course, as being in the computer group, Frodo was always a common name that always wound up as a server. You always had a Frodo, a Gandalf.
Well, there was always different universities had different. So my university, when they built their mainframe and eventually their VAX systems out, they named them after characters from Mary Tyler Moore.
Oh, that is so cool.
So there was Murray, there was Rhoda, there was
Ted Baxter.
There was a Ted, and there was a bunch of things. So, but other schools had different systems. Like it was kind of cool. There was the Star Trek ones, there was the Star Wars ones, there was might have been one of the Ivy Leagues had named after crayon colors in the 64 box. So it was very cute, like how that is, and that's something that it's not really a thing anymore. But yes, I enjoyed that too. Kind of even just discovering, like I remember Um, I remember it was my university. I was like Murray, Rhoda, Ted. I'm like, heard these names before, like like used in like what's the common theme here? Yeah. So
That show has, and you got me, don't have me talk about
uh,
television. That show has such great legs from the point of view of it. I think it's timeless, even though it's probably a little dated. I think I've watched those shows. I've had my children watch those shows, and it just carries, it's like, it's a timeless show.
Yeah, the
There are
writing
other,
was very well done. Like
yeah,
it's a classic for a reason.
it's a classic. I tried to show my kids Laugh-In a few years ago, and my wife and I sat down. We said, this was the funniest show of our time. And we turned on old Laugh-In, and it just didn't. It just didn't. It really didn't carry forward. It was just like, okay, we skipped that one. That didn't work. But yeah, Mary Tyler Moore was timeless. What a great show. Murray, what was it? Chuckles the Clown, best episode ever.
Oh yeah, I'll have to check it out. That now, the interesting thing is now with the cloud, or you could stream it. I don't know who has it. I don't know if it's on, but I mean the fact that you know you can watch anything at any time is, I think, is a indirect byproduct of how cheap storage and computers become and how commoditized it has.
Right.
So
Anything is available at any time. I just think about how anything I think about, I can just search for and find.
right.
Just amazing. How you can just find, and like if you're interested in genealogical records, I want to find out. I just recently was just like Google searching about my grandfather, and literally found records, where he lived, and the candy store he operated.
Oh wow.
He owned a candy store. So I found the records of the candy store, and and then because of like Google Maps, I have an old picture of the candy store from 1940, and then I can go to that same location today and look at, well, it's a bodega now.
Right. Wow.
Cool. There's the bodega where my grandfather's candy store used to exist. It was a candy store in 1940, and now it's 2000 some odd, and it's been a bodega. So kind of cool. All is online. So with this storage out there.
Yeah, I mean people talk about networks and things like that, but really kind of the backbone of how we experience the internet today, it's all built on storage. I mean,
Right.
every time, even if you have an S3 bucket, right? Somewhere in some data center somewhere, something's spinning up, unless it's SSD, but there's
Right.
some LED light that's flickering, or something's happening.
You go online to any online store, and you look at a product, and we won't talk about all the things they're capturing about you, but you look at that and you put it in your shopping cart, and you think, maybe I'll get it, but maybe not right now. And then you leave and you close your laptop and you go do something else. And maybe the next day you open up your laptop and you navigate back to that same website, and there's your shopping cart, and it still has that same product in it. Well, do you think you're connecting to the same server you were connecting to, 3 days ago or a week ago? No. And are you connecting even to the same process that you were running? No. And you may not even be in the same data center, but the storage remembers you. That storage is ubiquitous. It's sprayed out across the country. There's copies of it in multiple data centers. And so no matter where you came back to, and you just reconnect to that Amazon cart, or whatever cart you're in, Wayfair, there's your product, because the storage kept it, and you're probably connected to it, like you said, a different process, a different server, and probably a different data center. But the storage remembered that you put that in the cart. And of course, you got 50 emails along the way saying, hey, did you leave something in your cart? Why don't you go buy it?
Take the final step to buy that. Yeah, I've done that with a couple of online courses where, like, I'll put it in the cart and then I get distracted on my phone, right? And then I come back to my laptop, and then it's like it's in my cart there, and I'll get a couple of emails in between, like, hey, pick up where you left off. But you're right. I mean, and also too, there's whole new paradigms, right? I'm sure you have heard of this, and our viewers have heard of this too. Serverless, right? Serverless would not exist.
Right.
I have to be careful because somebody will say, well, actually, it would. But I mean, it's hard to imagine serverless existing in a world without kind of all the gadgets and stuff we have today,
Right.
and the architectures we have today, right? Because it wouldn't make sense. Like serverless, well, even just the term serverless just sounds like an oxymoron, right? How
Right.
could you do this without a server? Well, it's not really about that. It's about everything but your code being ephemeral. Where
Right.
your code runs, how it runs, what it does, that's ephemeral, but the actual kind of what triggers it and what executes it. And that is, I think, opened up all sorts of new architectures and new ways of thinking for developers. So this sort of technology, most data scientists were content to live in our data science world, and we're all excited about Chat GPT and all the transformers and stuff like that. But uh, could we have built these types of structures without this type of underpinning? I mean, maybe, but I think it'd be a lot harder.
Right.
You know, and this is kind of the unsung, the other unsung hero of kind of the innovations in AI or the data engineers. You'll hear, this model had, 15 billion input parameters, right? Well, how was that trained? Like how just the sheer effort that would go into, at least if you're doing this on prem or doing it kind of the old fashioned way, would have been just impractical, like the cost
Right.
alone. Now it's just a matter of, you pick a cloud vendor and you spin stuff up and you spin stuff down and you get a bill, right? So you
Right.
don't have to acquire the hardware. Once upon a time, I worked in Silicon Alley at a major retailer who was trying to build a book selling website. I think we can all figure out who they are.
Right.
But and before we sold the first book, right, we had dropped millions of dollars into hardware, the data center, the just the cabling, like just a lot of money went into that before the first book was sold. Now, the
Right.
true power of the cloud is if I wanted to start a bookstore today, whether or not it's a good idea, let's just suspend our disbelief, right? Whether or not that's a good idea, I could probably do it today on a credit card.
Right.
You know what I mean? Because I would have that elastic nature of the cloud. And I think
Right.
people, and correct me if I'm wrong, but I mean, kind of the underpinning of all these major hyperscalers that are out there, it's containerization, whether that's containerization of compute or storage, right? The fact that we don't have to think about it, I think, speaks how well products like Ceph and ODF, not saying that any one particular uses that, they have some kind of containerized flavor of storage,
Right.
but we wouldn't be able to just, using my, you know, Google Drive example, right? Just here, give us $2 extra a month. We'll give you more cars.
Right. 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 You don't want, but you bring up the really good point. If you were to open that bookstore,
Mm-hmm.
you're in the book business, right?
Right.
Or you're in the, information business, but you're in a business, you're not in the computer business, right?
Yes.
And you don't want to be basically an IT organization that happens to be selling books. Well, unfortunately, there is a model like that out there. There is, but skipping them, you're in that business of selling books, and you don't want to be in the business of maintaining a computer center. And I won't argue, but I think it isn't a bad idea. Selling books are doing great, by the way. Despite all the technology, people are still reading, and they're reading a lot. So the books aren't going away. Maybe the form you get them in, although I think a lot of people still cherish holding a physical book in their hand and turning the page. There's something super satisfying about that.
It is a very tactile experience, and there have been cases when I'll start with the ebook, but I want to have it in print.
Right.
Now, part of it is I don't get notifications
Right.
and get distracted as much on an actual paper book, whereas with
an e-reader, you might get distracted.
Right, with an e-reader, you'll get distracted. Whether, especially if it's on your phone or your existing device, where you'll get notifications. But with an actual paper book, it's very, you don't get bothered. So you're right. I mean, like, I was just saying that whether or not it's a good idea to go up against a particularly
Giant.
one giant. But I mean, not to discourage any potential booksellers out there, but the calculus has changed in terms of how one would start a business now. I mean, you could theoretically have a business idea, at breakfast, have a rough proof of concept website by lunch, and potentially in an extreme case, have your first sale by dinner. Like
Right.
it's not impossible, right? The barrier to that isn't the technology anymore. The
Right.
barrier to that is how well you can get your message out and acquire customers. It's
Right.
almost like frictionless computing.
Yeah. I mean, you would almost argue that, again, without using a corporate name, but a ride service
Right.
is a technology company because they're coordinating the cars to pick you up and drop you off and paying for the drivers and collecting your fees. And that's all about the technology. But they happen to be providing a car service that was kind of revolutionized, transportation in a way, because you don't have to, well, if you're a New Yorker like I am, you don't stand on a street corner and try to hail a cab in the rain. You just like go to your phone and go, get me a cab. That's cool. But really it's about the technology.
No, absolutely. Yeah.
Coordinating it and watching the car. Yeah. Being impatient, watching the car arrive and
I
getting
was
into the wrong one.
I was recently in New York City, and the for whatever reason, like where the GPS signal will triangulate you may not be exactly in front of the same store. So you kind of have to figure out where's the car going. But again, that's a new problem, right? Because I remember having to hail cabs too, and there's a certain skill to it. And if you
Or there's a skill to it. And then it was a cash business.
Yep.
So you had to have cash to pay the fare and enough cash. I was always calculating in my head, how much do I need to get where I'm going? And how do I make change? I don't want to make change. So will the fare wind up so that I can give the guy a certain number of bills that is a decent tip
Yep.
for the right, and he doesn't have to make change and give it back to me, because I did not want to be sitting there watching him give me change. I wanted to hand him n number of bills and get out and get to my destination, right? So all those calculations are no longer in my head anymore, because it's just click the phone and it's done.
Hey, now you have cognitive surplus to think about storage.
Right. So let's look
Let's
a
get
little
into
bit.
a demo. Yeah.
So real,
Mhm.
let me just say, so when we talked about Cephs, so Ceph, okay, solving those problems, being able to provide, oh, I got to share my screen. I'm
Mhm.
sorry. Oops, let me do that. And I will do my whole screen, make it easier. And I will switch over. So share, wait, I have to pick it and share. There we go. So I'm in OpenShift. So we talk about Cephs being something that solved a lot of problems, being able to provide storage cheaply, be able to provide scale for performance, and be very reliant. And one of the things that Cephs did was over time become containerized. So instead of physically installing binaries in the, and configuring the servers, we just packaged up the storage code, the management of the storage and all that into containers, so that it also was easy to install. And because it was containerized, it was something we could install in OpenShift, because OpenShift needs storage. Because when we talk about storage in OpenShift, and then by the way, I'm in OpenShift here, and I do have a storage section, and I have, when we talk about storage in OpenShift, we want something, we have storage that they talk about storage that is either container ready or container native. So container ready means that the storage exists outside of the container system, and that I have some type of linkage to get to that storage. So if I go into my storage classes here, I have a number of storage classes defined, but I installed OpenShift here on VMware. So it's a virtualized platform that I'm sitting on top of. And that's actually an interesting use case, because here I'm running virtualization to run my containerized platforms, because from a point of view of test and dev, that's a good thing because I can just spin up an OpenShift cluster really quick, do my testing, and then get rid of it. But then if I go into production, I might just go straight to the bare metal and install OpenShift right on bare metal and eliminate that middle layer. But in the meantime, it comes with some storage, and this is kind of container ready storage because it exists outside of OpenShift. So there's this class here, and there's a driver. It's called thin, and it will essentially create a volume for me. If I say I want a persistent volume claim on the VMware data store that my environment is living on. And I could have a storage array from somebody, and that storage array, again, it will exist outside, and I will go and grab storage off of it. And essentially then have to do a mapping of that storage, physical storage, to the physical server running, and then present that up into the containers. Here, I also happen to have Cephs installed. Now, Cephs is the containerized native version. Not Cephs, excuse me, ODF. ODF, OpenShift Data Foundation, is Cephs running fully containerized inside OpenShift. And so that's been stored. So you can see here, we add here this little part here. It says Data Foundation. And this is kind of my summary screen within OpenShift that is telling me a little bit about my storage. I see an overview screen, and I can see that I have a healthy, because the green check marks, I have a healthy storage system. I'm not using very much of it. I just installed, again, this is new or full. This is new. I just created it recently, but I can see my capacity. And I have a performance screen here showing, IOPS, latency, and throughput. So I get a little bit of summary of what's going on in my environment. And I have a little...
so if there was a glitch or a bottleneck, you would be able to narrow it down pretty quickly.
I would be able to sit. And yes, exactly. And there are other things here I can see that I built. I can have multiple storage systems running, and I've got one here. I could create new ones. I have a little bit about what's behind here, and I actually have some namespaces defined. But let's just go back, and I have my storage system here. Now, what that provides me is the ability to create persistent volumes. And here is like a list of all my persistent volumes. But really, an application makes a claim, a persistent volume claim. We'll go to all projects. And what that means is I request storage, and then I fulfill that storage by the system fulfills that by going out and creating a volume and then fulfilling that claim. So for every claim here is a claim called files. I actually have a little, let's just go down to an application, a little file browser application I built. And files is the volume that persistent volume claim I requested, and then the volume got built here, and that's the volume that actually is fulfilling that claim. And then over here I can see that it's existing on the file system, the CephFS file system, and that's the storage class that's providing that storage here. I have a second one here, which actually I did a snapshot. So I'm seeing here I did a restore of a snapshot. So you can see here I got a second copy of this volume because I asked for I did a backup and then a restore. So I can see the second copy I created. But that's my little application here. But so when I go back to storage classes, I can see the different types of storage I can request. So here is a file system. So here, if I request this as a storage type, I will get a file system presented to me. Here is RBD, and that's block devices. And here are my buckets, or my if I wanted to do a object store, I can request a object bucket. So those are the storage types I can request here. They all exist in fully containerized, running in the system. So this is kind of cool. What we've done, I should mention, is, to bring it back to this new year, is that we've provided ODF as through something, we're providing it through something we're calling Fusion. And Fusion has been, for the past year, IBM's offering to build a foundation around OpenShift, to be able to basically provide OpenShift and everything OpenShift would need from a point of view of data services. So I've actually installed Fusion, and if I go over to my operators.
So it's installed as an operator on side of OpenShift. So there's a really good tie-in between the two. That's interesting.
Right. And so if I go down to IBM Spectrum Fusion namespace, I see there's an operator here. And if I click on that operator, I can see the things it provides. But essentially, I have built a Fusion storage system on OpenShift. And what does that mean? I'm providing some services. What am I providing? Well, you can see the boxes I've checked here. I'm providing backup and restore, which the marketing folks would call data protection, but it's backup and restore to you and me. And I'm providing OpenShift Data Foundation. That's my foundation for storage. And I have a third storage class here called the Global Data Platform. So believe it or not, IBM had software-defined storage of its own before Ceph. In the early days, it was called GPFS. And GPFS was also designed to be a file system that was highly performant. It was a global parallel file system. That's what it stands for, GPFS. And it served a really good purpose and still does, as being a very high performance file system technology.
So is it globally distributed for speed or redundancy? Like if a natural disaster took out one particular data center, would it replicate automatically, or is that something completely different?
No, it does. It does do that. It replicates. It can replicate across data centers. Can be very highly reliable within a data center. It started, in that more traditional vein of file system, file system technology. It was built originally with the idea of SAN in mind. Like you would have multiple servers talking to the same set of drives. That way, if a server would fail, your data would still be available. But it really went after solving the parallel access problem, which meaning if I have lots of servers who all want to talk to the same set of data, well, we need locking. And locking, so that we're not overwriting.
Starts getting complicated as soon as you say blocking and locking.
Locking. I'm sorry, I meant locking.
Locking, okay.
We want locks. We want to basically be able to lock the data that if I'm doing a write, I want to make sure nobody else is doing a write at the exact same time. Otherwise, that would be bad. It's kind of easy to do when you have an operating system in one file system running on a server and everybody. So I've got applications talking. That's within the file system. But what if that file system spread out across multiple servers? It gets a little bit more complex there. And so that's where we start getting into this whole,
to say the least.
Yeah. How do I solve that problem?
So, I mean, is this an eventual consistency model? Is this last one wins, or are there weighted kind of?
It's actually actually, well, so it's IBM. So it was actually a token it's a token passing concept where you're passing a token, and whoever owns the holding that token can do writes. If you're not holding it, kind of like pass the baton, like a speaking stick. You're not
or a token ring for the kids out there who don't know what we're talking about. There's actually a pretty good Wikipedia article on it. So
so that what's important about that is that it was you're managing that, and the advantage of being a ring technology is that I don't have a centralized locking manager. And one of the problems with traditional clustered file systems were that you would have a lock manager And that guy owned the locks and then would hand them out to the servers who wanted to do the writes. And that one became a single point of failure, and it also became a bottleneck. So that's kind of like it scales so much and then it stops scaling because you hit that bottleneck. Plus it's a single point of failure. If that lock master goes down, you've got problems. So you have to have redundant lock masters. But if you have a distributed locking mechanism where everybody is participating, then if one guy fails, we're not so worried because we have another, we have everybody else owning a copy of the database. And so we continue. So scale out, and we won't get into all of the things about GPFS, which became Spectrum Scale. They renamed it, but now it's but
if anyone wants us to do a deeper dive into those topics, let us know in the comments below.
Right.
So I mean, I could geek out on this for hours, but I do know you can find it. And we chatted yesterday, and we geeked out pretty hard with some old tech stories. So
that was, and Scale was container ready, and now is moved into the container native world, meaning that you can run Spectrum Scale in containers on your OpenShift platform. So if you wanted to do that, you can. You're pretty much running just the client code, meaning you're and you have some type of Spectrum Scale infrastructure outside that you're connecting to. So if you're running Scale and you want to plug into that, we give you that capability here. But if you want to run 100% container native and everything is inside of OpenShift, you would typically migrate to doing ODF because that's a fully 100% container native solution here. And what's nice about this is that I could be running this here in my on my premise. I could be running it in the cloud. I can be running in some kind of mix, but I'll have the same services available to me wherever I'm decide to build this out. So that's really nice.
So where can customers or people watching this find out more? Like how do they get started with this? What's the best way to get started?
That's really good. Well, I mean, if you're running OpenShift or you can certainly just go to the operator hub and look for the ODF operator and then deploy that. Don't ask me about how that all gets licensed right now, but I just that is available to you. Now certainly you can still go to the Red Hat website and read about it, and you can go to the IBM website and read more about it, or these channels, but it's available to you as a native part of OpenShift. Fusion is kind of as the name implies, is the fusion or a collection of these services all brought together under one umbrella. So we're essentially just kind of wrapping that for you and making the installation easier, simplifying the install and simplifying the management a little bit. So we have this Spectrum Fusion operator here. If I install it, which I have, I come back to my installed operators, and as I mentioned before, I get these services as a collection. So it's kind of like a one-stop shopping kind of scenario. And there it has its own GUI. So after you install it, you go up to the dots here, and you can see Spectrum Fusion listed out. I already opened that up, so I can see my Fusion dashboard here. This is the version that was released last quarter. There'll be another one coming out this quarter, so we're trying to do an update every quarter. And there's an introduction here, and then you can see the services that are provided. I have my backup and restore. I installed that. I have ODF. I installed that. In fact, I installed ODF first, and then I let Fusion discover that ODF was installed. It installed and said, "Oh, you already did that. Okay, great. I'll just mark that running." And then I have my pane of glass here within Fusion, it just gives me an overview of my data foundation environment, a simpler overview of what I'm doing as far as ODF. I'm distributed across 3 nodes. I have 3 storage nodes that are running, and it just gives me my utilization and tells me that my environment is healthy. It's kind of simple, but the idea is I'm just trying to simplify my information here. I just wanted to let you know that you have it installed and what you're using so far.
Well, this is awesome. This is cool. I definitely, I'll definitely ping you because I have many questions. And if you have any questions, let us know in the chat. And if you want us to kind of dive into any particular part of this, let us know. And of course, be sure to like, share, and subscribe. Want to thank Josh for coming on, and really looking forward to get my hands dirty in the storage side of things, kind of going outside of the well-worn path of the data scientist and taking a look under the covers.
Okay, this was great. I enjoyed this, and maybe in future we can kind of dive down into like uses, where we would use it, how an
Oh
application
yeah.
might use it, and kind of explore some of the features, and get into kind of things you can do with it. So there's some fun features that that you can kind of dig out and use them for your applications. So we can do that kind of stuff.
Awesome. All right. Thanks for joining, and